All right, so today for graphing linear equations, it's important to note a linear equation is going to be an equation. However, when you graph it, it will form a straight line. So let's write that down. It's an equation whose graph is a line. Now, what exactly is a line? Well, a line appears to be just a straight line, like all these lines on the paper. However, mathematically, a line is infinitely many points that are created, that have created a line. So what I mean by that is, say I draw X and Y axis, and this is my line. Well, if I were to really identify this line, it's going to be all of the points that make up this line. There's so many that it appears solid. So think of it as really a set of compacted points that are so close together. Infinitely many points are in this line where it appears to be a solid line, but we do know that there's points lined up creating this line. So all of those points in there are going to be solutions to the equation. Okay, right, so example 1. We want to graph y equals negative 2x plus 1. Right, and when you do this, it's going to be a linear equation, which means it's going to be graphed and we're going to see a straight line. Where exactly is that straight line on the coordinate plane is what we're going to get to. So because there's so many points, like I mentioned before, on a straight line, we only need 2. If we got 2 points, we can grab a ruler, connect them, and we got a straight line going through where all the other points lie also, but we don't need them all. So I'm going to choose the easiest points, which are 0 and 1. And I'm choosing x because in my equation, x is the independent variable. I can pick whatever I want to plug it in, and then I will come out with my y value, which is my dependent variable. So let's see, y equals negative 2 x plus 1. And then I'm going to get my x, y. My goal is to get 2 coordinates and connect them. So to calculate my first y, I'm going to have y equals negative 2 plug in bubble plus 1. So for that, x value, it's going to be 1. Negative 2 times 1 is negative 2, plus 1 makes 1. Negative 1. And then that's my y coordinate. And what x did I plug in? I had plugged in a 1. So I plugged in a 1 into my equation, and I got y was negative 1. Next one. Y equals negative 2. I leave a plug-in bubble for my x coordinate. And then I add 1 to that. This time x is 0. Negative 2 times 0 is 0, plus 1 makes 1. And again for that one, I plugged in a 0 this time. So those are the 2 points that I needed to see what this line looks like on a graph. So for that, you need an x and a y coordinate axis. Quick sketch, x, y, and we're going to go 1 on the x-axis and down And then here we're going to go 0, 1. And that's my line. I'm going to connect these points, and that's the line I'm looking for. There's only one line that goes through those 2 points. So if you imagine it, it goes this way. So just to keep it straight, I'm going to look at the pattern. It looks like it's going down 2 over 1. Down 2 over 1. I'm going to fill in a couple more points to make it straight. Down 2 over 1. Keep the pattern going. Same thing here. Go left 1, up 2. That way as you're sketching this, you don't go crooked. And that is the equation of my line. I'm sorry, that's the line of that equation when I graph it. So again, these are the 2 points that I got here. However, your classmates picked different x coordinates. Say one of your classmates chose 2, then they're going to get this point here. If another classmate chose 1, 2, 3 for their x, say they wanted to choose a 3 here instead, then they would have gotten this coordinate for their y. They would have graphed this and extended it to the same points we chose. If a classmate would have chosen x is -1, they would have gotten this point here. So it doesn't matter which points you end up with, because we're all going to connect them and get the same path, the same line, slanted the same direction on the coordinate plane. The location is exact no matter what x coordinates you choose. You'll get a corresponding y. So let's look at the next example. Example 2. Let's graph horizontal and vertical lines. Well, this is a little strange, right? Because you're thinking, where's my plug-in bubble? How do I do this? Well, this concept is pretty simple. You still want 2 points, right? So if you want 2 points, then you get to pick your x's like we did last time. This time, I don't know, let's choose 1 and 2. Now, where am I going to plug in my 1? Where am I going to plug in my 2? I don't see anywhere to plug it in. That's because no matter what you do, y is going to always be -3. So in that case, you don't have to calculate anything. They're already telling you, no matter what you pick for x, make sure that y is -3. And there you go. Now for that, we'll graph it. And the more you do these, you'll become familiar with the shortcut without having to do this. So, 1, -3. 2, -3. And those are the 2 points I needed. And what does it look like when I graph a line going through those 2 points? It's this horizontal line, where all your y coordinates are -3, right? X, 1, -3. 2, -3. 3, -3. 0, -3. -1, -3. -2, -3. -3, -3. No matter what I do, I can keep going, but they're all going to be -3s. So that's going to be this line here. Okay? So then you'll realize, oh, whenever I have y equals, it's going to be crossing the y-axis at -3. You just draw it straight across. So with that being said, what do you think is going to happen when you see x equals 2? Can you predict what's going to happen with that one before we even pick some points? If the y-axis, for y equals -3, it's crossing the y-axis at -3, what do you think is happening when you have x equals 2? How's that going to look? Well, let's see. All right, so for graphing x equals 2, they're telling us x is going to be 2. So we don't have to pick our x's, we just know that x is going to be 2. And we need 2 points. So when x is 2, and it doesn't matter what the y's are, no matter what they're telling x is going to be 2. So, I don't know, let's say -1 and 1. So if I have -1 and 1 for my y, I'm picking the y here only because they're telling me that no matter what, x is going to be 2. So the points are going to be a lot of different points, but they're all going to have a coordinate of x is 2. So let's go ahead and graph those. 1, 2, -1. 1, 2, 1. Those are my 2 points, and the line that goes through them is this vertical line. Now, if you were thinking vertical, you're right. So, simple rule. If you got a y equals equation with a constant, it's going to cross the y-axis at that number. If you have an x equal equation, it's going to cross the x-axis at that number. So, these are going to be horizontal or the y equals a number, and the vertical are going to be x equals some number. So that's a simple, easy rule to remember. All right, so example 3. This one's a word problem, a real life application. So let's say we have a tropical storm, and the speed of the storm is determined by, we're going to call the speed y, is determined by y equals 2x plus 66 gives the wind speed. Of a tropical storm. And x is the number of hours after the storm enters the Gulf of Mexico. So an x is going to be representing hours. Okay, so we're going to try to figure out, when does the storm become a hurricane? So they're giving us some special notes that at 74 miles per hour becomes a hurricane. So when the winds become 74 miles per hour, obviously, or more, it's going to become a hurricane, not just a storm. So we're going to use this to model a linear equation and then use that to predict when will this storm, after how many hours will it be a hurricane, which in real life is something they need to do because we need to warn people when they need to do to be safe if they're in danger. Make a table. And again, we only need 2 points, so and let's use 0 and 2. So y equals 2 times x, which is my plug-in bubble. And then y equals 2 times x. Again, I left a plug-in bubble. And that plug-in bubble is where I'm going to put in my x value. 0 and 2. And that's 0, so this is going to be 66. And this is 4. And 66 plus 4 is 70. And now let's put in our x values that got us those numbers. 0 and 2. All right, so it's very important to have graph paper for these problems because we do need to make sure the graph is accurate and we make sure that it's straight. But for this, it's just a matter of understanding how to figure it out. So let me show you. You want to create a graph. And I am going to use the graph paper on my paper. And I'm going to go, let's go up to a couple hours. 1, 2, 3, 4, 5. And let's count by I'm gonna do a little break. When you see a zigzag like that in your graph, it means we took a piece out of the axis and we're going to jump to the bigger numbers. So let's jump to 60. And then we'll count by twos. 60, 62, 64, 66. This would be 68. This would be 70. And this would be 72, 74, 76, and 78, 79. We'll leave it there. Okay, so let's put these points on the graph. 0, 66. 0 and 64. 66 is here. Then we have 270. 2 will be 68, 69, 70. All right. And now from here, I want to draw my line and see when is it going to get over 74 miles per hour. So I'm going to look at the pattern. It goes 2, 2, 3, 4. So let's make it nice and straight. 2, 1, 2, 3, 4. 2, 1, 2, 3, 4. So follow this nice and straight. And when does it become 74? Right here. So let's follow that line. And the answer is 4. 4 hours. So after 4 hours, this hurricane, at this point, it's a storm. Oops. And then from here over here, it becomes a hurricane. So this was the point at which it became a hurricane. And then as the more time goes by, obviously the hurricane gets worse before it gets better. And there you go. That's the real life application, how we use linear equations to predict future results in data.